Okay. Today we're going to be doing, starting brand new chapter 8.1, relations and functions. We're going to be going over domain and range, input, outputs, figuring out what the function might be, seeing if the set of data or the relation is actually a function or not, if it works or not. Now, as you can tell on the vocab what I've written here, the relation, that is the set of ordered pairs. That itself is a set of ordered pairs. The domain then, let me get my page. And I have the arrows written here, so whenever we have a set of ordered pairs, say I have an ordered pair -2 and 5. What is the -2? The x or the y? It is the x. And this is always the y. And if you forget, they're always alphabetical order, x and y. Now when you look at that ordered pair, we can give them names other than just x and y. One of them is the domain and one of them is the range. Which one of these is my domain? The -2. The first one, this one, is my domain. And this one is my range. Another way to remember that, those also alphabetical order, just like x, y. This one's your domain, this one's your range, alphabetical order as well. Then, like I have arrows drawn over here, your domain is also known as your input. So therefore, your x is also your input. What is your y then? That is your output. Please put this in your notes, this little diagram to help you refer to so you know which ones. This is your x and y. And know that they all relate in those terms as well. So your x is also known as your domain, and that is your input. Your y is your range, and that is your output. If I have a whole bunch of ordered pairs, I have a set of ordered pairs, what is that called? Now here I just have one, but what if I had a whole set of them? What would it be called? That is called our relation. Okay, let's practice. Now here's just a little visual. This isn't in your notes, but this kind of gives you an example. Where could I pull the words up here? Let's move these around. Where do you think, well, first of all, what is the toaster itself? What do you think we should drag to the toaster? The toaster is the function. Because what does that toaster do? What's its function? It toasts, right? It heats it up and toasts it. That's its function. So what is the bread and the waffle and the bagel considered? That is our input, because that's what we start, that's put in there. We put toast in, or we put bread in and we get toasted toast. We put a waffle in, it comes out toasted. Put this bagel in, comes out toasted. The function is the toaster, it's toasting. So what are all these three things considered? Those are our outputs. Now, which one of these columns is our domain? The input the domain or the output the domain? The input. Remember, alphabetical order, if you don't remember, the D, the output is the range. All right? It's a little visual. And another one. Here, I don't believe this one's in your notes either, so let's just practice this one. See if you can figure this out. If my input is a 4, the output, whatever my function, whatever I do to that 4, turns it into a 9. That same exact function, if I do that to a -7, it'll turn it into a -2. And then what is the input? What can I do to the 0? What function can I do to the 0 to make the output become a 5? What function am I doing to all three of those numbers? Plusing 5. So if I plus 5, so these are my x's, right? My inputs, these are also known as my x's. These are also known as my y's. So if I go 4x, so if I go x plus 5, my 4 is x, do I get 9? Yes, I do. If I go negative 7 plus 5, do I get a negative 2? And 0 plus 5, does that equal 5? Yes. So the function there is x plus 5. Now you have to be kind of careful because sometimes they'll say figure out the function on your homework or worksheet and you'll go, oh yeah, this is plus 5, and then you'll just quit because it worked for the first one. But you got to make sure you check all of them because it might work for one but not the other two, so then you're back to the drawing board. You have to figure out what you have to do to all of them to get them to work. So don't let them trick you by thinking, ooh, I got it on the first time. Make sure you check the other ones to see that they also work. Now here, it says identify the domain and the range of the relationship represented by the table below that shows one Norway spruce tree's height at different ages. How many of you guys have pine trees in your yards? They're pretty fast growers. I mean, they grow pretty good rate. Now here they're telling us they measured at the age X, at the age of 5, it was 13 what? Yep, the Y is 13 feet. At 10 years old, it was 25 feet, 15, 34, and so on. So let's list our relation. Our relation is the ordered pairs of what and what. What's my first ordered pair? These are my X and these are my Y's. 5 and 13. 10, 25. 15 and 34. 20 and 43. And the last one being what? 25 and 52. Thank you. Nice job. So there's our relation. The domain of the relation is the set of all what? The domain is the set of all, I'll give you a hint, an I. What is it? Input. Or the input are the what coordinates? The X or the Y coordinates?
X.
Right. That goes back to that little chart that I gave you. The range is the set of all outputs. And it's also known as what? The range are all your
Y.
ranges are all your Y coordinates. So let's list our domains. What if we were just to list the numbers of domains here? What are my domains? The domains are all my what? X's, right? And those are all right here. So list all our domains. 5, 10, 15, 20, 25. Okay, so on the x-axis, that's where they would be. They'd be somewhere, there'd be one here at the 5, there'd be one at the 10, 15, 20, and 25. Those are all my inputs. That's where all my inputs are at, my x's. So then, all my outputs are what? The y's, okay? These are my x's, these are my y's, so they are 13, 25, 34, 43, and 52. That's how tall they were at those years. Okay? So on the coordinate plane, the y, so these dots are going to be anywhere from somewhere up here into the 13, 25, 34, 43 going up this way. They're on your y axis. Now they want us to say, okay, represent this relation as indicated. So first they want us to plot this relation on a graph. So let's do that. graph the coordinate pairs as points in a coordinate plane. We've had lots of practice with that, so let's plot these on the graph. All right, yours look like mine. Got those plotted. Now for B, they want us to do a mapping diagram, and you have to do one of these today, I believe. And down here is what your mapping diagram looks like. First, you have to list the inputs and the outputs in order. Okay, so let's list all the inputs and outputs in order. My inputs are what? Okay, my inputs are going to be the -3, the -2, the 1, and the 2. So what's the first one? In order from least to greatest, I'm going to have, or excuse me, I think we'll go from biggest to smallest. What's the biggest one? I'm sorry, I didn't hear. 2. 1, -2, and -3. Now for the outputs, we have what?
3, 2, 1, -2, -3.
Everybody got their inputs and their outputs? Any questions? All right, these were my X's, these were my Y's. Now to finish, we have to draw arrows from the inputs to their outputs. We have to match them up now. So what was matched with the 2? The 2 has to go drawn to the -3. The 1 has to go to a 1, and one of them has to go to a 3. One of them has to go to a 1, and one of them has to go to a 3. I'm going to circle that right there for a reason. I'm going to show you why. What does the -2 go to? -2. And what does the -3 go to? A +2. So there is your mapping diagram. Right there's what we just did, was a mapping diagram. Now there's something about this mapping diagram, and I circled it, and we're going to talk about it here in a minute. Because they're going to ask us, tell whether the relation is a function in that example 1. The one where we have the trees growing. When I was 5 years old, it was 13 feet and so on. Is that relation a function? Is or is not a function? Who wants to take a guess? Is this or is this not a function? Because right now we haven't learned really how to tell the difference. Who wants to just take a guess? Who thinks it is or isn't by recalling what you wrote in your vocab?
Is it?
Isn't? Let's just take a guess. Who thinks it is? Who thinks it isn't? Okay, interesting. I'm going to tell you that the relationship is a function. All right? And how about B? I'm going to go to B now. And I'm going to tell you that this relationship is not a function. Okay, so now you know. But now let's figure out why. Maybe you can see why and why not, thinking about what we wrote in our vocab. Why is this one is a relationship or a function, and this relationship is not? Who can tell me the difference? Why is this one and this one isn't? Want to guess?
For B, it isn't because of the 2 ones, I'm guessing.
Exactly. That is an excellent guess. This one is not because it repeats the ones. What are the ones called? They are your inputs. Let's look at our vocab. And what else is our input known as? Right. And a function, a relation with the property that for each input there is exactly one output. So you can only have one. And let me show you why. Oh, where did it go? Right there. If we were to graph the trees, they would be like at 5 years old, they'd be 13 at 10, and you see how the graph would be like this if we graph the trees? But in this one, when we graphed it, when our x repeated itself, we go, x was 1, and then we had one here. And then for every input, there's exactly one output, but this one had 2 outputs. The x, your range, or excuse me, your x, your domain, or your input can never repeat. Because you end up with 2 of them. You end up with more than one input. You gotta have exactly 1 for 1, and that makes that, you're off. All right, you can't, and that jumps to right here. Whenever you see a vertical line, that takes us, I'm going to jump right here ahead a little bit. The vertical line test in example 4. In the graph below, no vertical line passes through more than one point, so the relation represented by the graph is a function. Okay, because you have a point here, 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 here. And there's no 2 of them on a vertical line. They all share. That means none of the x's repeated. Now, because that would be like, I could have 2 and 3. That's fine. Okay, so here's 2 and 3. If I plotted that, then I'd have more than, this one's 2 and -1. See how it would fail then because I have 2 x's? That fails, so it wouldn't be a function if that was added on there. But what if I had 2 and 3 and I repeated not the x, but I repeat the y? And what if I go 4 and 3? I'd plot that one. 4 and 1, 2, 3. Oh. Does that fail the vertical line test? No. We can have them on the horizontal. That doesn't matter if there's 2 of them going that way. So the y, the output, that one can repeat. You're fine. It's just this very first one, the x. That can't repeat in your relation or it's not a function. So now we know the relation is not a function because the what? What happens here? The x or the domain repeats. So how about this one? The relation is a function because what? What can we say? Think of the vocab we just read. Because for every input, remember that? Because for every input, you have exactly one output. And that's right from your vocab on the front page. This makes sense as a single tree can have, what, blank heights at a given point in time. What could I fill in there? Can have only one. Now this is you can kind of get a little picky about this. If you're doing this, you're going to have to measure it like at the beginning of the year. Because if you have a tree, if you measure it at the beginning of the year and then you measure it at the end of the year, could it be different?
Yeah.
So you got to make sure you're measuring it at the same time every year, right? Next one. This is pretty much what you're going to be doing in your worksheet. Identify the domain and the range of the relationship and tell if it is a function or not. So on your worksheet, you will list the domains. If you want to do this, domain, fine. So, and the range. Yes or no. Domains, ranges, and yes or no for the function. List the domains for me in number 1.
Do you want them in a specific order?
Nope, that's a good question. Do they need to be in a specific order when we list them here? Nope, they only have to be in order when you do the, what? The mapping diagram. Good job. Here they do not need to be in order. So what are my domains?
-5, -3, -1, 2,
Perfect. And my ranges?
2, -1, 0, 3.
All right. Now looking at that, raise your hand if you think it is a function. Is not a function. The yeses are winning. So if you tell me that yes, that is a function, I can go up to my domains and there better not be anything repeating. Is there anything repeating?
No.
Nope, then you are correct. Next one, domains, -4, -3, 0, 1, 2, 3, and 3. Ranges, -3, 2, 0, -1, 3, 1, -2. Who says yes, it is a function? Who says no? Woo, you guys are quick. Not bad for a Friday. And no, it is not. Why not? Because the domain repeats right here. We have 2 3s. So, wah, wah. Can't do that. Can I have repeating ranges? Does that matter?
No.
No, it does not matter. These can repeat down here. It does not matter. All right, we just talked about example 4, the vertical line test. In the graph below, the vertical lines shown pass through 2 points. Which 2 points? Are yours marked on your graph for you like this?
Yeah.
They are? Okay. So they map the, so by the graph, it is not a function. Now there's a question that comes along here. What if I, Mrs. Lennon, what if I have a point on the x-axis or the y-axis here, and I have one down here? What if I have 2 points on the y-axis? Does that matter? Does that pass the vertical line test? No, it does not. That would be a sad face too. That is not a function. It still fails the vertical line test. It's on the y-axis. Okay, your worksheet for today, 8.1.